Hi, you're welcome once again to my YouTube channel. If you're just watching for the first time, my name is Frances Onako, and this is a channel for learning chemistry and discussing real life issues. If you're yet to subscribe, please subscribe. You will not lose anything by subscribing. Subscribe, hit the notification bell so that anytime I post new video, you will get it. So today we are going to talk about Dalton's atomic theory. Dalton's atomic theory, that is the topic we have for today. Sorry, I've been off for quite a long time. It's due to some personal issues which needed to be solved. So I'm back, and I promise you I'll be posting new videos steadily. So let's get started.
Over the horizon, over the horizon.
Welcome back. So today's topic, like I said, is Dalton's atomic theory. Many of you have heard about John Dalton. It's a popular name in chemistry. And whenever you hear about atomic theory, you think of Dalton. Now, in 1808, he proposed the atomic theory. You know, those scientists, scientists, the real scientists, not what, I'm just sorry to say, not what we have today. These were the people that were really doing the work, finding out things, experimenting things, and proposing theories. So John Dalton proposed the atomic theory, which is summarized as all, number one, there are 5 of them. Number one, all elements are made up of small indivisible particles called atoms. Number 2, atoms can neither be created nor destroyed. Number 3, atoms of the same element are exactly alike, but differ from atoms of other elements. So just like in your family, you are alike in your family in one way or the other. You are surely alike because you all came out from the same womb. But you differ from siblings of other families. So one can use it to remember this number 3. Atoms of the same element are exactly alike, but they differ from atoms of other elements. And number 4, when atoms combine, they do so in simple ratios. That's why you can say one atom of hydrogen and combined with 2 atoms of oxygen to form water. So you can say 1:2, though they combine in simple ratios. Then number 5, all chemical reactions or chemical changes result from the combination or separation of atoms. That is, when atoms combine, there must be a chemical change, and when they separate, a chemical change must occur. So all chemical changes result from either the combination or separation of atoms. These 5 atomic theories must be said in order. You can't just jump from one to the other. You cannot say atoms are made up of small elements are made up of small indivisible particles called atoms. Then you jump to number 5 and say when atoms combine, they do so, then there must be a chemical change. A chemical change must result from the combination or separation of atoms. No, it must be in that order. Okay? For it also help you for easy remembrance. Now, however, just like I told you, these scientists, they don't rest. They keep on experimenting, they keep on trying, they keep on observing, they keep on forming hypotheses, and then they keep on experimenting, and then they end up getting theories. So you don't just come out and propose your theory, and everybody will just sit down and say, okay, that is it, without it having to undergo some observations, some experiments, there must be, the people will observe and then go through it a lot and then know whether it can stand the test of time. That is what science is all about. That's what chemistry is all about. So this atomic theory, however, could not explain electrolysis. Have you seen where it has a loophole? It cannot explain electrolysis, even though it is partially supported by experimental evidence deduced from the law of conservation of mass, the law of definite proportions, and the law of multiple proportions. But because it cannot support and so it cannot explain electrolysis, it has now become there's now a loophole, and new discoveries were also made in order to modify this Dalton's law. So Dalton's law was modified. Now I will let you know the modifications and the reason why this was modified. Things keep on evolving. And chemistry is not left behind. So, modifications of Dalton's atomic theory. The first, he stated that all elements are made up of small indivisible particles called atoms. However, Rutherford, another scientist, popular scientist, now discovered that an atom is built up of three particles: proton, electron, and neutron. So you cannot say that it is an indivisible solid piece because it is built up of three particles. So it is not indivisible. Okay? So that is how the first one was modified. Then the second one that said that atom can neither be created nor destroyed. That is a popular saying. The atom can never be created nor destroyed. However, it still holds good for the law of conservation of mass. It holds good for that. However, during a nuclear reaction, such as fission of uranium-235, the nucleus is broken up into smaller units, which form simpler atoms. Have you seen it? Which form simpler atoms, while a tremendous amount of heat energy was released. So these changes that occur during nuclear fission has already destroyed the atoms of the element involved. Okay, so this has now modified. These atoms can neither be created nor destroyed. The fission of uranium-235 has shown that atom can be destroyed into simpler pieces, and because of the tremendous amount of heat energy released, it shows that it has already been destroyed. So atoms can neither be created nor destroyed, unless you're just talking of law of conservation of mass. Then the third one, the atoms of the same element are exactly alike and differ from atoms of all the other elements. However, the discovery of isotopes has already made this one to be questionable, because, for example, chlorine is an isotope, okay, and it has different neutron number, which also affects its atomic mass, meaning it also has different atomic mass. We live at the atomic mass, even though they have the same atomic number, but they have different atomic mass and they have different neutron content. So because of that, they differ in their neutron content and hence in their atomic mass. So you cannot say that they are exactly alike in all aspects. They are not. In all that, they differ in their neutron content, hence in their atomic mass. For example, isotope of chlorine can have it has 33, it has 35.5. Sorry, it has 35.5, it has 37 as the atomic masses. Yeah, even though the atomic number is 17. Yeah, but it has 35 and 37 as the atomic masses. So you cannot say it's exactly alike in all aspects. Okay, in every aspect, no. Then for number 4, during a chemical reaction, number 4, number 5, the same. When atoms combine, they do some separation. That one, no problem was found with it. It still holds true for the atomic theory. However, number 5 has a loophole. During a chemical reaction, there is a combination of atoms in small whole numbers. This is true for inorganic compounds. Okay, this is true for inorganic compounds. Sorry, I'm talking of number 4. It's number 5. When atoms combine or separate, there is a chemical change. That one holds true. Yeah, but the one of when atoms combine, they do so in simple ratios, also has a loophole. Yeah, which I'm going to explain now. This is true for all inorganic compounds. Yes, because it contains few atoms per molecule. However, carbon has a long chain of atoms. So you cannot say that when carbon atoms combine, like in organic compounds, where carbon has a long chain of atoms. They don't do so in simple ratios, okay? Because they have a long chain. So this particular theory does not hold true for all atoms. Okay, it does not hold true for carbon atom. Yeah. So with this, we have come to the end of this particular lesson, Dalton's atomic theory. I hope you learned something from it. Yeah. And my comment box is always open for anyone that has a question, and I will also post some important information in the description box. Okay, don't forget to subscribe and hit the notification bell, and thank you so much for watching. See you soon. Bye.